Aluminum. Over 1.5 million pounds produced every day at full capacity. Mining. More than 6 million tons of lignite mined each year. Power generation. Enough electricity produced to power a medium-sized city. This is Alcoa Rockdale Operations, one of the largest smelters in the United States. Large ingots of aluminum weighing up to 45,000 pounds, 1,200-pound foundry ingot, and 1,500-pound primary ingots are shipped from Rockdale Operations to rolling and fabricating facilities across the country. From these ingots are produced an array of products for a variety of consumer and industrial applications. Aluminum powder made at Rockdale Operations is used as a major component in fuel for NASA's solid rocket boosters. Aluminum, the most abundant metallic element in the Earth's crust, is rarely found free in nature. There are numerous aluminum-bearing minerals from which aluminum can be extracted. However, most aluminum is produced from bauxite, an ore that is rich in aluminum oxide. Most bauxite deposits are found in the Caribbean area, South America, Africa, Russia, East Asia, and Australia. Through a complex refining process, bauxite eventually yields a fine white powder of aluminum oxide, or alumina. It is this material that is used in the electrolytic process. The process for making aluminum is a refinement of the same basic smelting process developed in 1886 by Charles Martin Hall, requiring alumina, carbon, and electricity. Of course, many improvements have been made in the design of equipment and in operating techniques since the 19th century, but the basic process remains essentially the same. The smelting of aluminum is only part of the story of Rockdale Operations. Within this huge complex are over 1,100 people and a large infrastructure dedicated to safely serving our customers, delivering quality anodes, molten metal, and ingot, making the location the best it can be. Alcoa's electrode plant at Rockdale supplies carbon anode assemblies to the pot rooms. Along with alumina, it takes more than 1/3 of a pound of carbon to produce a pound of aluminum. The production of carbon anodes is in itself a major undertaking. Several thousand carbon anodes per week are produced by the carbon plant and baked in the carbon furnaces. In the carbon anode area called the green mill, calcined petroleum coke and pitch are brought into the plant by trucks and the Rockdale, Sandow, and Southern Railroad, and stored in large silos. The coke is ground, screened to size, and then blended with pitch and recycled used anodes. This material is loaded into batch mixers where it is steam heated and mixed, then moved through a series of conveyors to carbon presses. Under 1,500 tons of force, the mixture is pressed into green anode blocks. The green anode blocks are conveyed to a central loading area, placed on large trailers, and transported to the carbon baking furnaces. Here they're placed in pits, then carefully sealed and baked at temperatures of up to 2,100 degrees Fahrenheit for about 18 days. Computer-controlled firing frames control the heating process. After the blocks are baked, they are removed from the pits, loaded onto trailers, and carried back to the central loading area to be readied for the rotting room. In the rotting room, baked carbon blocks are joined with a copper rod stub to form the finished anode assembly. Used rods are reconditioned, then carried by automated equipment to the pouring station, where they are joined with anode blocks using molten cast iron. Completed carbon anode assemblies are carried by trailer to the pot rooms. To get aluminum metal, alumina powder brought by rail to Rockdale must be smelted or reduced, using the electrolytic Hall process to separate the aluminum and the oxygen. This is done by dissolving powdered alumina in a cryolite bath, inside large, carbon-lined electrolytic reduction cells called pots. When a powerful direct electric current is passed through the bath from the carbon anodes to a carbon cathode, the alumina is reduced to aluminum metal. Heat generated by the electricity keeps the bath liquid at about 1800 degrees Fahrenheit, so more alumina can be added to make the process continuous. As liquid aluminum builds up on the bottom of the pots, it is siphoned off. The pots used in smelting at Rockdale are up to 15 feet wide and 40 feet long. They are electrically connected so that they all work at the same time. Collector bars embedded in the cathodes in the bottom of each pot carry the current to the next pot in series. At Rockdale Operations, between 72 and 80 pots are linked together in a single room. 2 rooms linked together form a pot line. Like most aluminum smelting plants, Rockdale has several pot lines. All the lines together make up the pot rooms, the heart of the aluminum production process. Molten aluminum in the pots is analyzed for purity, then assigned to fill specific customer orders for sheet ingot, high-purity aluminum, foundry metal, atomized powder, or commodity pig ingot. The aluminum is then removed from the smelting pots in large containers called crucibles and sent on to the cast house or to the atomizer. Alcoa's cast house at Rockdale converts molten metal into aluminum products. Over 1.5 million pounds of molten metal per day are hauled in 5-ton crucibles from the pot rooms to the cast house by large molten metal trucks. Here, the metal in each crucible is weighed, analyzed, and then either poured into 1,500-pound molds or sent to one of 6 holding furnaces that maintain the metal temperature at about 1,300 degrees Fahrenheit prior to casting. Before molten aluminum is cast, it is skimmed and alloyed with one or more other metals to give it strength, brightness, or other special properties required by our customers. From the furnace, the metal flows through a trough and a filter system that removes any impurities. Ingots weighing as much as 45,000 pounds are cast in one of 2 direct chill vertical casting units. Much of the plant's metal is cast into ingot. These are shipped to aluminum fabricating plants to be rolled into sheet. Primary ingots weighing 1,500 pounds, more commonly called pigs, are poured in the cast house along what is called a mold line. Pigs of up to 99.95% pure aluminum are shipped to other Alcoa plants and outside customers throughout the world. Alcoa operates its largest, most technologically advanced atomized aluminum powder facility adjacent to the Rockdale smelter. The Rockdale atomizing facility was originally constructed in 1966. As the demand for high-quality aluminum powder ballooned in the years following, the Rockdale atomizer increased its production and refined its ability to consistently and economically produce more than 200 grades of high-quality, fine atomized aluminum powder. This powder is a major component in fuel for the solid rocket boosters that send NASA's space shuttle up and through the atmosphere. In 1991, the Rockdale atomizer was named the sole supplier of aluminum powder utilized in shuttle launches. Why did Alcoa build an aluminum production plant at this site? The answer is lignite, a soft coal found in abundance in central Texas, which could provide an efficient energy source for aluminum smelting operations. How did this lignite form? Early geologic studies reveal that at one time in our ancient past, the coastline of Texas encroached some 100 miles inland, forming a broad arch from southwest Texas to Texarkana. Had Rockdale existed then, it would have been a coastal town. As the Gulf retreated, it left low and gently inclined marshes and meandering rivers. Rich, abundant vegetation eventually was left deposited in marshes and swamps. Layer after layer of decaying mass eventually was transformed into peat, each layer alternately covered with sand and clay. Over time, repeated coverings added weight and increased pressure on the peat, and eventually changed the peat to lignite. The typical lignite seam ranges from 5 to 15 feet in thickness. 13 lignite seams have been identified in the Sandow mine deposit, 10 of which are mineable. 9 seams of lignite have been identified in Three Oaks mine, 8 of which are mineable. Surface mining has been a part of the Rockdale area's industrial activity since the early 1900s. In 1952, Alcoa, searching for a long-term, low-cost fuel supply for its aluminum smelting operations, came to Rockdale, where a plentiful supply of lignite fuel existed. The company formed a mining agreement with Texas Power and Light. Under this arrangement, lignite fuel from Sandow Mine would be used to power 3 electrical generating units, which in turn would supply electrical power to Alcoa's new primary aluminum production plant. This new plant became the first aluminum-producing facility to use lignite as a fuel for electrical power generation. The mining operation from the 1950s through the 1980s delivered 2 million tons of lignite annually to 3 Alcoa power units. In the early 1980s, with the construction of a 4th power generation unit, that output was increased from 2 million to 6 million tons of lignite per year. The first stage in the mining process is the removal of overburden, the layers of sand and clay covering the seams of lignite. 2 large drag lines are used. Each of these drag lines has a working weight of 13 million pounds, a 360-foot boom length, and a bucket that holds over 100 cubic yards. With one scoop, this bucket can pick up 200 tons of material, enough to fill 10 to 12 large dump trucks. The bucket itself weighs 100 tons when empty. The 2 drag lines combined can move about 50 million cubic yards of overburden per year. To put this in perspective, this would be somewhat equivalent to the total material excavated for the Panama Canal. The uncovering process runs 24 hours per day, 7 days per week. As seams of lignite are exposed, the material is prepared for loading. Hydraulic excavators and front-end loaders then load the lignite into coal haulers, picking up 15 to 20 tons with each bucket load. The lignite is hauled to primary crushers by a fleet of 160-ton capacity coal haulers, which then dump the material into the crushers. About 18,000 tons of lignite per day are mined, yielding an annual production of 6 million tons. Coal loading and hauling operations require an extensive support infrastructure, including maintaining haul roads and controlling dust conditions, as well as maintaining a large fleet of heavy mobile equipment. Lignite is conveyed from the primary crushers to the operating stockpiles located at the power plant. The lignite is then reclaimed from the stockpile, crushed, and conveyed to the boiler furnaces, where it burns as a massive fireball of over 3,500 degrees Fahrenheit, heating the huge boilers that produce superheated steam. This steam is used to turn the turbines, which then turn the generators to make electricity. The Sandow Power Generating Station consists of 4 steam electric generating units, 3 of which are owned and operated by Alcoa, and a 4th owned and operated by TXU Energy. These 4 units have a combined electrical output of about 1,000 megawatts per hour, enough to power a medium-sized city. In the early 1970s, Alcoa began an active reclamation program, 5 years before legislation was passed requiring restoration of mined lands. Today, Alcoa's Sandow mining site occupies 5,000 acres, and its permit encompasses about 18,000 acres in Milam and adjoining Lee County. Three Oaks Mine in Lee and Bastrop counties encompasses about 16,000 acres. Some 250 to 300 acres of land are mined each year. Before mining can begin, an extensive permitting process is required. Sandow Mine operates under the regulations of 22 state and federal agencies. The permitting process requires a thorough and careful evaluation of pre-mining conditions and how they will be affected by mining and reclamation activities. The permitting process requires the development of detailed plans for post-mining operations, including reshaping the land, reestablishing wildlife and their habitats, and monitoring air and water quality for many years after the land has been mined. These permits serve as guidelines for Alcoa's reclamation program. Alcoa's goal is not only to restore the land, but make it even more productive than it was before mining began. Reclamation is an ongoing process. As the dragline digs the overburden, it fills the pit area in which lignite has been removed. Part of this operation results in mounds of overburden, which must be leveled within a specified time after coal removal from the active pit is complete. The process continues with shaping and contouring the land to its approximate original contour. The construction of drainage ways and ponds is included in this contouring phase. Soil stabilization is an integral part of reclamation. To help in this, revegetation of the area is accomplished during the first available planting season after final leveling of the spoil. Mulch is added to the soil in order to add organic matter and to increase moisture retention during initial plant establishment. This mulch is made from an annual harvest of 10,000 rolls of hay that is grown on previously reclaimed land. One of the goals of a reclamation program is the establishment of diverse plant species and the sustainable development of native grasses, as well as improved grass varieties. The density and kinds of vegetation are based on land use planning. Trees, shrubs, and other types of vegetation are reestablished as much as possible according to density and type of original habitat. Since its reclamation program has begun, Sandow Mine has planted over 500,000 trees of more than 30 different species on previously mined and now reclaimed lands. Since 1980, Alcoa has reclaimed over 6,000 acres of land. Such reestablishment of vegetative habitats enhances the return of wildlife populations. The development of wetlands and ponds is an important part of land reclamation. Ponds are stocked with native fish, providing a plentiful supply of food for waterfowl and small animals alike. Even small creatures are part of the reclamation program. For instance, honeybees are introduced into reclaimed areas to help in vegetative reproduction. These efforts are rewarded with a successful honey production program. The mine's quality habitat attracts many unique and diverse wildlife species. During a recent birding tour in 2004, a pair of American bald eagles was observed building a nest. This was the first documented nesting of bald eagles in a mine site in Texas. Alcoa's reclamation activities have been nationally recognized by the U.S. Department of Interior Office of Surface Mining. Sandow Mine received the award for Excellence in Surface Coal Mining Reclamation in 1991 and again in 1998. In 2004, the mine received the prestigious Sentinels of Safety Award from the National Mining Association and the U.S. Department of Labor's Mine Safety and Health Administration. These awards are given annually to those mines with the best safety records in the nation. Superior recognition came in 1998 when the Office of Surface Mining named Sandow Mine's reclamation program the best of the best among all 5,400 surface mines in the nation. Such recognition underscores the company's commitment to protect and improve the environment now and for years to come. It was before mining began, reestablishing wildlife habitats, and by being a good neighbor, contributing to the quality of life of local communities. This is Alcoa Rockdale Operations, where its employees are making it the best it can be.